Lesson 7-4, Scientific Notation. Our essential question is, how do you write a number in scientific notation? Well, scientific notation is a method, it's kind of like a shortcut for writing really large and really small numbers so that you don't have to have all of the zeros. What scientific notation looks like is, it's a times 10 to the power of n, and a is a number from 1 to 9. So anything from 1 to 9, and n is an integer. So it could be a positive or negative number. So a is a single digit, a number from 1 to 9, and then n is an integer. This first slide is asking us to write the number in scientific notation. So write it in scientific notation. So remember, we're looking for a times 10 to the power of n, and a has to be a number from 1 to 9, from 1 to 9. Now, you may notice that the first number is 5,300, so it's clearly not a number from 1 to 9. So what we're going to do is we're going to write the decimal point where it starts, and we're going to move that decimal point over. So I need to move it over 1, 2, 3 spots here, because I can only have a number from 1 to 9 for my value for a. So now I've moved the decimal point over so that it's after the 5 or between the 5 and the 3. I don't have to write these trailing zeros now. I do need to make sure that I count them though when I'm figuring out my exponent for n. I moved the decimal point 3 places, so that is my exponent on 10. So 5.3 times 10 to the third power is the same as 5,300. Remember, 10 to the third power, 10 times 10 is 100, times another 10 is 1,000. So 5.3 times 1,000 would be 5,300. So it should make sense that it's equivalent. The next one, my decimal point starts out at the end again. I have to move it over until I've got just that single digit from 1 to 9. So I'm going to count as I move. 1, 2, 3, 4, 5, 6. If I stop right here, I would have 68. That is not a digit from 1 to 9, so I have to move over that 7th spot so that I get 6.87 times 10 to the 7th power. Because I moved my decimal point 7 places. 7 places. The third one, I need to move the decimal point 1, 2, 3, 4 places. Because again, remember, I need just that one digit. Just that one digit from 1 to 9 for the a value. So 2.01 times 10 to the power of, I moved it 1, 2, 3, 4 places this time. So 2.01 times 10 to the 4th power. Now notice that I was able to cut off these trailing zeros when I wrote my decimal portion of the problem. You cannot cut out a 0 if it's in between two non-zero digits. You need to keep it. Okay, this last one, my decimal point is right here. So this one is just the number 7. That's already, it's already a digit from 1 to 9. So I can keep my 7. So to write this one in scientific notation, I moved my decimal point 0 places. So 7 is the same as 10 7 times 10 to the 0 power. Remember how we learned that 10 to the 0 power, that anything raised to the 0 power equals the number 1? So it should make sense then that 7 times 10 to the 0 power, which is 1, 7 times 1 is 7. So writing it in scientific notation, you would still need to include this part. You wouldn't want to just say, well, it's just 7 and leave it at that. You need the times 10 to the power of n, and in this case, n is just 0. Okay, now we're going to work on some small numbers. So we're still going to write our answer in the same form. We still need a to b from anything from 1 to 9. So this time we've got the zeros. These are small numbers, so the zeros are on the left. So we're going to be moving our decimal point to the right. This first one, we need to move it 2 places. So 3.4 times 10 to the power of, instead of 2, it's -2, because these are small numbers. So if we wrote 10 squared, which is 100, that wouldn't make any sense at all, because this number, 0.034, is 34 thousandths. So it's a very small number. The next one, we move our decimal point 1, 2, 3, 4, 5 places. So it's 5 times 10 to the -5th, because it was 5 places that we had to move it to the right. The third one, 1, 2, 3 places we need in order to get a digit that's not a 0 on the left of the decimal point. So 1.25 times 10 to the -3rd power. And then the last one needs to move 1 place so that it's on the other side of the 7. So 7 times 10 to the -1st. Now we're going to reverse that process, and instead of writing the number in scientific notation, we now have to write it in standard form. Remember when the exponents are positive. Positive exponents represent our larger numbers. So positive exponents, we are going to have to move the decimal point to the right. So 5 places to the right would be 1, 2, 3, 4, 5. I'm going to have to add in 2 zeros here to finish off the number. So I have 3, 2, 0, 1, and then 2 more zeros. So my number would be 320,100. Remember 10 to the 5th power. 10 to the 5th power would have 5 zeros in it. So it would be 100,000. So 3.201 times 100,000 is 320,100. So that should make sense. The next one, I only have to move it 2 places, so it's 632. The next one, 3 places. But remember that the decimal point right now is after the 4. So 4 times 10 to the 3rd power, if I move it 1, 2, 3 places, I have to put in 3 zeros. So it's really 4,000. Again, 10 to the 3rd power is 1,000. So it should make sense if you're doing 4 times 1,000 that it would equal 4,000. Okay, now on this last one, my exponent is 0. So that means I'm moving the decimal point 0 places. So that means it's staying right where it's at, 9.03. All right, last but not least, we have our negative exponents. So negative exponents are the smaller numbers. Negative exponents, smaller numbers. So we are going to be moving our decimal point to the left to represent these numbers. So left 1 means right here, so it's 0.76. Left 2, 1, 2. I need a 0 in front then, 0.0345. Left 7. So on this one, I'm going to move it, right now it's after the 8, I'm going to move it once to go around the 8, and I still have 6 more places, so 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 zeros I need. 6 zeros, and then my 8. And the last one, 5 places. The first place goes around the 1, so 1, 2, 3, 4, 5. So I need 1, 2, 3, 4 zeros. 1, 2, 3, 4, and then my 1, 5, 2 for my final answer. So this lesson we're focused on writing numbers in scientific notation and in standard form, so going back and forth between those two different forms for numbers, and making sure that you can do this with positive exponents and with negative exponents. These kinds of problems you will definitely see in science class, thus scientific notation. Because in science class you work with some really large numbers and really small numbers. You should be able to write a summary now, and make sure to check my homework calendar for the homework problems.